Guys, what you see behind me here is a old 1950s or 40s model Cummins. This thing is what they refer to as a iron lung Cummins because of the blower there. All right, what this thing is, what it does, it powers a water pump over here, or actually a water tower. All right, most fire systems now are air systems. However, I guess in the old style, what they'd have is that they would have something like this generator here powering a big water pump, and then they've got a water tower outside here. And when you have your fire head go off inside the building, what would happen is that when the fire head goes off and there's a leak, then be a loss of water pressure, and then this panel behind me would see that loss of water pressure, and then it would, kick the motor on. Well, anyways, I got called out here for this thing because it wouldn't start. And like I said, I'm not 100% knowledgeable on these antiques, and this is definitely an antique. But basic troubleshooting, and it kind of got me to where I'm at now. So let me flip the camera around here and I'll show you what's going on. Okay. So this is actually a positive ground setup, and it threw me for a loop at first because I was like, well, these are positive cables, and this is a ground stud, and that's where your hot would normally be, but it's connected to ground through this contactor and this contactor as well. And it took me a minute to kind of get my shit together, if I'm going to be honest about it. But then, while I was trying to figure it out, I actually found this old manual here, and it shows exactly how this thing's supposed to be wired. Well, anyways, basic troubleshooting, I found that when this contactor's pulled in, it wasn't any continuity between here and here. All right, so at first, the first thing I did was just see if I could possibly just buy another one. Couldn't find one, and then I thought about it. I'm like, well, this is a 50s model piece of equipment. In the 50s, they actually built stuff to be worked on. So I was like, you know what, let me see if I can actually take this thing apart. I was like, because it's probably very simple, a solenoid and some contacts, and sure enough, it was. And pretty much this one looks just like this one. And solenoid pulls in, and then it would send in this case, it would send ground from here to here, and once it sends it out, it would send it out to the starter, and then that's what allows it to start. Well, on this one right here, the contacts here will burn up. Okay, school bus time. All right. Now. So what I'm explaining here now is what caused this contactor to weld itself shut. With electronics, there's actually various different ways that would have possibly caused this contactor to weld itself shut, but the most basic thing that would happen is what would normally happen in any electrical situation when you're using a solenoid. When you're closing the contacts on it, you generate heat. That's because of your amp flow. Okay. Say if you've got a high load, so say you've got a starter motor that's getting weak, or you say you've got some weak batteries that are not producing enough amperage to actually allow the motor to spin over fast enough to start, so the contacts have to stay closed longer than normal, you would generate a lot more heat. And with that heat, you have welding. Now, what another possibility is that if you have a weak starter or weak batteries, you're creating a lot higher load, but you have a low voltage or a less than needed voltage, and you're still trying to supply the same amount of amps. That's also what can cause the welding of the contactor. Okay, so we know that we got one contactor that was welded shut, and we got one contactor that the contacts were essentially just burnt open on. Okay, so the contactor that's a little bit out of the frame here, that one has a contact that you can pull up on, and that will supply voltage from side to side. And then the other one, you actually have to go over to the control panel and press a start button for. The reason it's like that, I'm not really 100% sure, but I do know why there's two different contactors. Pretty much there's two banks of batteries there that are wired in series for 24 volts, and what it is just one is it's a redundancy situation there. So if one battery pack doesn't start the power unit, the other one will. Okay, so I ended up what you're going to see here in a little bit, when I try to energize the starter, it doesn't do anything. Okay, once again, I thought, okay, maybe I've got a issue where my contactor's not pulling in, or either the contactor's not pulling in, or just the power's not getting to the starter. So I actually had the tech there, I had him press the start button for me, and I checked with my meter on the solenoid on the starter, and it's getting voltage, but it's just plain and simple not energizing. But it's not arcing or doing anything odd like that, So you'll see here in the next part of the video that I actually pulled the starter off, and you'll see that the starter's actually destroyed. Alright, so where we last left off, I tried to start the power unit and it wouldn't start. The contactor would close, but it still wouldn't energize the starter here. Okay, so what I did then, I went and I pulled the starter off, because I was pretty certain prior to this anyways that the starter itself was bad, because with the contacts welding, it would have meant that the starter would have stayed engaged at some point or another. So pulled the starter off and I took it, and I wasn't expecting this kind of damage, but I wasn't really expecting this, but took it off and pulled the end cap off and seen that this was all tore up. We ordered a new starter, and we're going to install that today, and ordered two new 24 volt relays as opposed to those contactors, and we're going to wire them up. We've got to change the nose cone here, because there is a difference between this one and this one here. This one is more triangulated in shape, whereas this one is almost like a 4-bolt flange. It's just missing the one flange over there, where the triangulated one is a little bit different. Give me 1 second and I'll show you that. See, you can see how this one is more shaped like a triangle, where this one is shaped more like a square without this last corner. So we're going to flip-flop those edges there, or those end nose pieces, and we're going to go put it on, and we're going to see where we're at then. Alright folks, I had to do a little bit of swapping some parts, more so than I thought. So this here is the gear that come on the new one. Alright, this is an 11-tooth gear, whereas the old one is a 10-tooth gear. Alright, generally your odd numbered gears can interchange, and your even numbers can interchange. So say if you got a 9-tooth starter gear, it'll interchange with 11, or if you got a 10, it'll interchange with a 12. However, this one didn't work, so had to flip-flop those. If you ever have to do this, it's actually really simple. What you'll do, you'll take your nose cone off, obviously take that off just so you can be able to get in here to where the that fork is. All right, and you'll take the brush cap off, and like this one right here, it's just got 2 cables that go in. You'll have to take loose of this one here, then there's one on the bottom here, there's another one there. Just take the cable itself off, you can hang it to the side, and you'll be able to take the whole armature and slide it all the way out. Once you slide the armature out, this right here, you'll be able to pull it out of the fork, and then swap the new one in, slide everything back together, and that's how you do it. So I'm gonna put the new nose cone on, or the old nose cone back on. flip-flop those, and then that should be the end of all my parts swapping, and then we can put this bastard on and see what it does. All right, got the new starter on. Got two 24-volt starter relays in place of the old contactors. So let's see what happens. Over here, and we're gonna put it over in manual, and let's see what happens. Okay folks, you'll see the starter's back off. In the last shot, you would have seen that the starter was engaging, but it wasn't starting the motor. Okay, and you'll ask yourself, well, why is the starter back off? Is it a failure with the starter? No, it's not a failure with the starter. It was an oversight on my behalf, because when I had the starter ordered, I did not realize, or I didn't think about this, that there's a right-hand rotation starter and there's a left-hand rotation starter. Okay, so this gear here come off our original starter. Okay, and you'll see it ratchets to back to the right. Okay, so it's supposed to spin to the left. Okay, this starter right here actually spins to the right when it's engaged. So guess what? This would always stay ratcheting. And the reason that is that if it ever kicks back, it won't tear the starter up, you know. Hopefully it'll just hit the ratchet and, you know, just that'll happen. Okay, so here's our original gear that come off of here, and you'll see it ratchets back to the left, and it would spin and lock to the right. So oversight on my behalf. I'm actually going to go pick up the correct starter now, and actually this is one of the things, you know, it pays to be in front of your parts person when you're ordering something. I actually sat down with my parts guy, and we ordered the correct starter, like that looked exactly like the old one. Same tooth count, same nose cone, with nothing have to be changed on it. So there you go. Sometimes when you call them and say, hey, look, I need a 24-volt starter for XYZ, you know, sometimes, you know, things can get crossed up. So anyways, I'm going this morning to go pick up the correct starter. We're going to go put it on, and I will show you that in the next shot. Okie dokie folks, I had to get away a good ways away from the building there so that you could actually hear me talk. You see there in the background, there's my service truck and the water tower and the building that motor's housed in. If you like what you've seen in this video, just let me know, make a comment, or hit me up on Facebook on my business page, Coleman Mechanical. This is the kind of stuff that I get to work on my days off from my real job. So hope you enjoyed. Thank you.